Hi students, today we'll conduct an experiment to investigate how temperature affects the dissolving rate using particle theory. But before we get into the lab session, it's always better to remember the basic concepts and what we are going to test. Quick recap time. Who can tell me what kinetic energy is? Yeah, you. Good try. Does anyone else wants to give it a try? Good one. Kinetic energy is the energy possessed by an object due to its motion. Now imagine all the particles in the water as little bumper cars. What if those bumper cars are parked and not moving? Right? That's a solid. All particles are smushed together, not moving. Now, if the water is cold, these bumper cars are moving like as they are stuck in the traffic, slow, barely bumping into each other. But when you heat it up, these cars are going to race around like a race cars. Imagine if you toss up a teddy bear into a bumper car track. Would it get shredded faster by slow cars or by the race cars? Of course, by the race cars, right? Now, please don't try this experiment of throwing toys into an actual bumper car at a fun park. Hypothesis time. A hypothesis is a testable guess about what you think will happen, often based on the information that you already know. As the temperature goes up, the rate of dissolution goes up too, because the water molecules are going to move faster, which is what we learned now. The sugar will dissolve faster in a hot water than in a cold water. That's our scientific hunch, and that's what we call it as hypothesis. Does anyone disagree? It's always good to be able to understand the concept as a real science student and question it before we start seeing the evidence. Okay, here is what we are going to looking to learn at the end of this experiment. You'll learn how to be a scientist in the labs, about collecting, processing, and analyzing the data, how to spot the number patterns, and making graphs to solve real problems. So at the end, I hope all of you will become an expert in conducting experiments, collecting accurate data, and recording data accurately, and be able to spot the pattern of how this data is going to give us a story and the information that it is going to give it to us. Now, the fun bit, the experiment. Follow closely, even if you think you know what's coming. Every desk will have three students. You need to find your group. Each group will get three beakers like this. But before we start, safety first. Put your safety gears, goggles, and gloves. If the safety look isn't for you, the rest of the lab isn't going to happen for you. Seriously, no safety, no experiment. Can you all give me a thumbs up if that's clear? Great. Okay. Now, the step number two, you need to label your beakers like hot, warm, and cold. Use the labels and the markers right over there. So you'll have three beakers, each one will have a clear label on that. Firstly, you will pick up the warm beaker and fill it up with 200 ml of water. So how do you know 200 ml? Just up to the top mark here. So you fill it up to the top, and there you have. Okay, the warm water bucket is labeled over there clearly. Now, using your measuring spoon that's there at the table, you will find you'll have to get one scoopful of sugar. Just flatten the top. Don't have to be scientific about this. And then you put the water into the sugar into the water. And then the clock starts now. So one scientist will start the timer. Hands off once the timer is started. Now you will stir the solution gently with your stirrer. One smooth circle every 2 seconds. This isn't an egg whipping competition, so I don't want you to create a sugar tsunami. It takes longer. Be patient. And watch for the sugar to be dissolved. So keep stirring slowly and watch for the sugar to be dissolved. And all three of you will confirm that you can't see any undissolved sugar, whether you look it up from the top or from the sides for at least 10 seconds. Once you do that, then stop the clock. Each person notes the time on their record sheet. So I want each of you to note it separately because teamwork means we have got a backup. If someone sneezes and misses the data, the group isn't going down the ship. Once recorded in the sheet that's kept at your desk, you will then continue the experiment by discarding the water that you have just tested into the sink, and then you will refill it again with with the warm water, and then you will conduct the experiment 3 times. So you will do warm water 3 times before you move on to the hot water, which is there in the kettle, and then with the cold water, which is there in the ice bucket. So you will do 9 times. So 3 times with warm, 3 times with hot, and 3 times with cold. You will also be able to record every single one of those experiment results. Don't try to fight over small differences in terms of the level of the water or the level of the sugar. Be as consistent as possible throughout your experiment. Now, seriously, don't taste your sugars. They're not for you to eat. At the end of the experiment, you will create a record sheet which will look similar to what I have here on the table. So you will enter the 9 readings in there. The goal, what's our goal? We'll compare the time taken for each temperature setting, and we are going to look for the patterns. Now, as you've seen before, we know that the hot water beaker is going to take less amount of time to dissolve the water, and that's going to be the fastest. And then it's going to be warm, and then it's going to be cold, taking the longest of all. That's our hunch. Okay, here's what we will be testing. We're going to change one thing, measure one thing, and keep everything else steady. That's how we make it fair. So, what are we going to change? That's right. The water temperature is what we are going to change, and that's called independent variable because that's not dependent on anything. What are we going to measure? The time for sugar to dissolve. That's called a dependent variable because it depends about on the independent variable, which is the water temperature. We keep all the others as the constant. We call them as a controlled variables. We control them and not allow them to change. The controlled variables in this experiment are the amount of water, the sugar, and the stirring speed. So it's very important you keep your stirring speed constant throughout your experiment. Let's keep it real. If your results are widely different from another group, don't freak out. Just stay calm, discuss within your group, and repeat. If you know there was a mix up, own it. Restart the test. No bonus points for getting it wrong and pretending it otherwise. Failing, fixing, and retesting is the real science. So we head in. Safety quiz time, like a flight attendant style. What are the gloves for? No, we're not doing any mystery investigations here. The gloves are to keep your hands safe from hot water, sticky sugars, and any breakages. Why do we wear goggles? Right, to protect the eyes from any splashes. Now, let's see 3 real hazards. Now, it's not the earthquake or cyclone or volcanoes. It's hot water burns, the glass breakage, and the sugar spills. Remember, you're a scientist on a bumper car. You must take these safeties seriously. Otherwise, you'll end up with head injury. One final time, brake safety, you're out. That's simple. If you spot any dangers, a spills or a breaks, stay calm. Don't be a hero in trying to fix things. Call for help. You have me and you have the lab attendants in the lab, so call for one of them. The step by step instructions of what we just spoke is on your table. Take a couple of minutes to read them before you start the experiment. Does anyone else have got any questions before we head in? If you've got any questions during the experiment, I'm sure you can find me on the lab floor. All right, let's get started and make this a fun. Once you have your reading in the paper entered in the Excel sheet I provided you, you will see that it produces a line chart and a box and whisker chart. Line chart will show you the trend line, and that's where we are going to start our analysis on.